Three, look up at the night sky on a clear, dark evening. We all do it. We stare at those cold, piercing points of light, and our minds naturally drift to the same inevitable question. Three, is anyone out there looking back? And more importantly, if they are out there, will they ever come here? Science fiction has spent a century training us to believe that the universe is a bustling ocean, and with enough time, enough technology, and enough willpower, crossing the void is simply a matter of building a better ship. We imagine faster than light travel, folding space, and grand interstellar armadas appearing on the horizon. But the universe does not care about our imagination. It cares strictly about the laws of physics. And those laws have constructed an invisible, impenetrable fortress around our little blue world. A fortress made not of stone or steel, but of empty space, immense time, and the absolute limits of energy. Today, I'm going to walk you through the brutal, undeniable reality of interstellar travel. I'm going to show you why the distances between the stars are not just inconveniently large, but fundamentally prohibitive for any physical craft. We will break down the absolute speed limits of the cosmos and the sheer, mind-bending energy required to move even a single grain of sand across the galaxy. Before we begin tearing down the illusions of science fiction, take a moment to subscribe to Brian Greene Theory. We explore the deepest, most profound mysteries of reality on this channel, and you will not want to miss what we uncover. Now, let us strip away the fantasy. Let us look at the raw, beautiful, and profoundly isolating truth of our universe. Why is Earth so lonely? The answer is written in the very fabric of space-time itself. To understand why the cosmos is a fortress, we first have to understand the sheer, crushing scale of empty space. Our human brains are simply not wired to comprehend true cosmic distances. We evolved to understand the distance to the next valley, the distance to the river, or maybe the distance across a continent. Imagine you get into your car and drive down a straight highway at 100 kilometers per hour. A typical long road trip might take you a few days to cross a country. Now point that car straight up into the sky. If you could drive at that same highway speed to the moon, it would take you about half a year of non-stop driving just to reach our closest celestial neighbor. That is our backyard. What about our local campfire, the sun? At that same driving speed, it would take you roughly 170 years to reach the sun. Several lifetimes of continuous driving just to cross the innermost layer of our own solar system. But cars are slow. Let us talk about the ultimate speed limit of reality itself. The speed of light. Light travels at nearly 300,000 kilometers per second. To put that into perspective, in a single second, a beam of light could wrap around the equator of the Earth about 7.5 times. It is unimaginably fast. When you flip a switch in a room, the darkness shatters so quickly that the illumination appears instantaneous to your eyes. Now, let us point that beam of light out into the deep ocean of the Milky Way galaxy. The closest star system to our sun is called Alpha Centauri. To the naked eye, it looks like a single prick of light, but it is actually a neighborhood of 3 stars. If you shoot a laser beam from Earth toward Alpha Centauri, traveling at that absolute maximum speed of 300,000 kilometers per second, it will not arrive instantly. It will take over 4 years to get there, 4 entire years traveling at the fastest speed the universe will allow, just to reach the house next door. And here is the first major problem for our hypothetical alien visitors. You cannot travel at the speed of light. Nothing with mass can. We will dive deeper into the terrifying mathematics of that later, but for now, we must accept that any physical spaceship is restricted to traveling at a fraction of the speed of light. So Let us look at the fastest physical objects humanity has ever thrown into the void. Consider the Voyager 1 spacecraft. It was launched decades ago and is currently hurtling away from us at about 17 kilometers every single second. That is over 38,000 miles per hour. It is a speed so immense that a bullet fired from a rifle seems to be crawling in comparison. If Voyager 1 were pointed directly at our closest stellar neighbor, how long would it take to cross that gap? It would take over 70,000 years. Let that sink in. 70,000 years. Think about human history. Just 5,000 years ago, we were writing our first words on clay tablets. 10,000 years ago, we were just beginning to figure out agriculture. 70,000 years ago, our ancestors were barely making the journey out of Africa. The span of time required to cross the shortest possible interstellar gap using our fastest technology is far longer than the entire history of human civilization. This is the foundation of our isolation. The space between the stars is a vast, silent desert. We often picture aliens hopping into a sleek metallic saucer and zipping over to Earth as if they are taking a weekend cruise. But any biological entity attempting to cross that desert faces a journey that outlasts empires, outlasts species, and perhaps outlasts the geological stability of their own homeworld. And yet, distance is only the first wall. It is simply the geography of the problem. What happens when a highly advanced civilization decides they do not care about the distance? What happens when they decide to build an engine powerful enough to cut that 70,000-year journey down to a single lifetime? That is when the universe stops playing nice. That is when the laws of physics transform from a passive landscape into an active, insurmountable barrier. So let us assume distance is not a deterrent. Let us assume an alien civilization looks at a 70,000-year journey and simply says, we must go faster. We must build a ship that can cross the void, not in millennia, but in a single lifetime. To do this, they cannot rely on the slow drifting speeds of our current space probes. They must push their spacecraft to a significant fraction of the speed of light. Let us be generous and say they want to travel at 50% of the speed of light. At that speed, a journey from the closest star system would take less than a decade. It sounds entirely reasonable for an advanced society, but this is where the mystery deepens and where the universe reveals its absolute intolerance for rule breakers. To understand the cruelty of physics, I want you to imagine pushing a broken down car down a flat street. It takes a lot of effort to get it rolling, but once it is moving, it becomes a little easier to keep it going. Now, imagine a bizarre reality where the faster the car rolls, the heavier it becomes. By the time you get it to a walking pace, it weighs as much as a heavy truck. By the time it reaches a running pace, it weighs as much as a freight train. No matter how hard you push, the sheer weight of the object exhausts your energy, making it impossible to push it any faster. This is not a science fiction concept. This is the bedrock reality of our universe, proven by Albert Einstein over a century ago. Einstein showed us that energy and mass are deeply, intimately connected. They are, in fact, the exact same thing in different forms. When you accelerate an alien spacecraft, you are pumping colossal amounts of kinetic energy into it. As that ship pushes closer and closer to the absolute speed limit of the cosmos, a profound transformation occurs. The energy you are using to push the ship actually adds to the ship's resistance to being accelerated further. To the universe, the ship behaves as if it is becoming heavier. To increase the speed from 50% to 51% of the speed of light requires a monumental amount of energy. To go from 90% to 91% requires vastly more. As you approach the speed of light, the energy required to accelerate approaches infinity. But the nightmare of interstellar travel does not stop there. Because to generate all that energy, the alien ship must carry fuel. This brings us to the most brutal, unforgiving law of space travel, something physicists call the rocket equation. Imagine you are packing your car for a very long road trip, but there are no gas stations along the way. You have to bring all the fuel you will ever need with you, but gasoline is heavy. So, you load up the trunk with hundreds of gallons of gas. Now your car is incredibly heavy. Because it is so heavy, the engine has to work twice as hard, burning twice as much gas just to move. So you have to attach a trailer to carry even more gas to compensate for the weight of the gas you just added. But now the trailer is heavy, so you need a second trailer to carry the gas needed to pull the first trailer. This is the tyranny of rocket mechanics. In space, to move a massive ship, you need a massive amount of fuel. But you also have to push the fuel itself to accelerate a spacecraft the size of a standard commercial airplane to half the speed of light using perfect 100% efficient nuclear fusion. You would need a fuel tank roughly the size of a mountain. And that is just to speed up. When you reach your destination, you have to slow down, which means you have to turn the engines around and fire them again, requiring yet another mountain of fuel. Even if an alien civilization mastered antimatter, the most energy-dense substance allowed by the laws of physics, the sheer volume of fuel required to cross the void is utterly catastrophic. They would need to harness the energy output of entire planets just to send a single modest ship to our solar system. It is a monumental, almost impossible expenditure of resources. And yet, incredibly, the energy problem is still not the most terrifying barrier. Because even if they harness the power of a star and build a ship that can fly near the speed of light, they are about to run into an invisible wall that will tear their majestic vessel apart. Let us imagine, against all odds, that our theoretical alien civilization has solved the energy crisis. They have built an engine capable of harnessing the power of entire planets, and they have constructed a ship that can accelerate to 90% of the speed of light. They have conquered the vast distances and the astronomical fuel requirements. They are finally on their way. But right here, out in the dark, they collide with a brutal paradox. We think of deep space as a perfect silent vacuum. We picture an empty void where absolutely nothing exists to get in your way. But space is not perfectly empty. It is sparsely populated with stray hydrogen atoms, microscopic grains of cosmic dust, and wandering molecules. In our daily lives, a speck of dust is completely harmless. If a grain of sand hits your car while you are driving down the highway, you do not even notice it. But physics tells us that kinetic energy is exponentially tied to speed. The paradox of interstellar travel is that the faster you go to shorten the journey, the more deadly the empty void becomes. Imagine driving a car through a gentle rainstorm. The water splashes harmlessly off the glass. Now imagine driving that same car at 3,000 miles per hour. At that speed, the water does not splash. Those gentle raindrops hit the windshield like armor-piercing bullets, instantly shattering the metal and glass. Now, scale that up to the cosmos. If a spacecraft is traveling at 90% of the speed of light, hitting a single microscopic grain of sand is no longer a minor inconvenience. Because of the extreme relative velocity, that tiny grain of sand strikes the hull with the explosive energy of a massive bomb. At near light speed, the alien ship is moving through the interstellar medium so rapidly that the incredibly sparse hydrogen atoms become a concentrated, blinding beam of lethal radiation. The empty vacuum of space transforms into an unrelenting, apocalyptic storm of kinetic bombardment. The ship is not flying through a quiet ocean. It is flying through a cosmic sandblaster. To survive, the ship would need armor hundreds of feet thick, which makes the ship incredibly heavy, which brings us right back to the impossible fuel problem we discussed in the last chapter. But let us be generous. Let us pretend these aliens have developed some impenetrable energy shield. They can magically deflect the dust and survive the radiation. They are invincible. They still have to confront the deepest, most beautiful, and most tragic paradox of reality, the paradox of time itself. We experience time as a rigid, unchangeable ticking clock. A second is a second. A year is a year, no matter where you are. But Albert Einstein proved that this is an illusion. Time is not absolute. Time is a physical dimension that stretches and bends. And the rule is simple but profound. The faster you move through space, the slower you move through time. If the alien crew travels at 90% of the speed of light, their onboard clocks, their biological aging, and their perception of reality all dramatically slow down relative to the rest of the universe. To the crew, the journey to Earth might feel like it takes only 10 years. They will age exactly 10 years. But back on their home planet, the clocks are ticking at a normal pace. For the society they left behind, centuries will have passed. This is the ultimate heartbreaking cost of crossing the stars. Interstellar travel is a one-way ticket to the future. If an alien crew sets sail for Earth, they must accept that everyone they have ever known will be long dead before they even reach the halfway point. Their home civilization might rise, fall, and turn to dust while they are locked in transit. They become ghosts, disconnected from their own history, completely isolated from the world that built them. So, they brave the kinetic storms, and they sacrifice their entire civilization to the cruelty of time dilation. They do all of this, and they finally arrive in our solar system. They point their sensors at Earth to look at us. But what they see will fundamentally break your brain. Let us rewind the clock for a moment. Because to understand the terrifying truth of what these aliens experience when they finally arrive in our solar system, I must first ask you a question that completely breaks our everyday understanding of reality. Why did they leave their home planet in the first place? What made them choose Earth? Science fiction always assumes that aliens detect us, realize we are here, and immediately pack their bags to come say hello or to conquer us. But this assumption completely ignores the most absolute, unbreakable law of the universe. The speed of light is not just a speed limit for physical objects. It is the absolute speed limit for information. It is the speed of causality itself. Think about how you experience the world. When you look at a tree across the street, you assume you are seeing that tree exactly as it is right this very second. And for all practical purposes, you are. But technically, light takes a tiny fraction of a second to bounce off that tree and reach your eyes. You are not seeing the tree in the present. You are seeing the tree as it existed a fraction of a second in the past. Now, let us scale that up. When you look at the sun, you are not seeing the sun as it is right now. You are seeing the sun as it was 8 minutes ago, because it takes 8 minutes for its light to cross the void of our solar system. If the sun magically vanished this exact instant, we would not know about it for 8 full minutes. We would still see it shining in the sky. We would still feel its warmth. When you look up at the night sky, you are not looking at the universe as it exists today. You are looking at a cosmic time machine. You are looking deep into the past. And this is where the reality of interstellar contact breaks your brain. Imagine our highly advanced alien civilization lives on a planet circling a star 1,000 light years away from us. They build a miraculous, impossibly powerful telescope, point it at Earth, and zoom in to see who is living here. They do not see massive, sprawling cities. They do not see airplanes or satellites. Because the light reflecting off the Earth right now will not reach them for another 1,000 years. The light entering their telescope today left the Earth 1,000 years ago. They see humanity living in the Middle Ages. They see knights on horseback and wooden ships sailing across the oceans. What if they are farther away? What if they are 65 million light years away? If they look at Earth today, they do not see humans at all. They see giant reptiles walking across a massive supercontinent. So if they decide to fire up their engines and travel to our world, who exactly are they coming to visit? Let us imagine they live relatively close, say 100 light years away. They finally receive our earliest radio signals. They hear the crackling, static-filled broadcasts from the early 20th century. They realize they are not alone, and they immediately launch their fastest ship, traveling at 90% of the speed of light. By the time that ship arrives here, more than a century will have passed on Earth. The humans who broadcast that original signal are dead and buried. The society the aliens thought they were coming to meet no longer exists. This is the terrible, isolating truth of the cosmos. The universe enforces a strict, permanent quarantine. We are separated from the rest of the galaxy not just by oceans of empty space, but by insurmountable walls of time. Any attempt at interstellar communication is fundamentally a dialogue between ghosts. You are speaking to a civilization as they were thousands of years ago. And by the time they hear you, your society will have completely transformed, or perhaps died out entirely. They arrive in our solar system expecting to find the ancient civilization they saw through their telescopes, only to find a completely different world. But even this tragic realization is not the end of the story. Because if they do somehow overcome the distance, the energy barriers, the kinetic bombardment, and the time dilation, they face a final, very horrifying barrier that makes all of their effort completely pointless. So let us assume the impossible has happened. Our theoretical aliens have defied the colossal distances. They have conquered the infinite energy requirements. They have survived the apocalyptic kinetic storms of deep space. And they have accepted the devastating, heartbreaking loss of their own timeline. They have arrived. Their ship slows down and they enter our solar system. They look upon our little blue marble. Now, we must confront the most uncomfortable, humbling reality of all. This is the hard truth of the cosmos. Listen closely. As a species, we suffer from a profound evolutionary narcissism. We flatter ourselves. We watch decades of science fiction movies where vast alien armadas descend upon our cities, blotting out the sun, entirely focused on us. We imagine they are here to steal our water, harvest our resources, or conquer our territory for themselves. We instinctively view ourselves as the grand prize of the galaxy. But this is a failure of human imagination, driven by our own history of fighting over tiny patches of land on a small, isolated planet. The universe operates on entirely different scales of abundance, and the laws of thermodynamics are brutally indifferent to our ego. Let us look at resources. Science fiction loves the idea of aliens coming here to drain our oceans. But physics tells us a completely different story. Water, composed of hydrogen and oxygen, is one of the most incredibly abundant chemical compounds in the entire universe. It is literally everywhere. There are massive drifting clouds of water vapor in deep space. There are entire moons in our very own outer solar system, like Europa and Enceladus, that hold vast, very deep oceans of pure water capped by ice. If a highly advanced alien species needs water, they can simply harvest a dead comet or melt the ice of a quiet, lifeless moon in zero gravity. 3. Why on earth would they choose to plunge their massive ship deep into the crushing gravity well of our planet, just to suck up our salty, biologically contaminated oceans? To a physicist, a planet is a trap. Earth has a massive gravitational pull. To land a gigantic starship here and then attempt to take off again, it requires fighting the exact same tyrannical rocket equation we discussed earlier. It is a thermodynamic nightmare. It would be like a billionaire traveling across the globe, scaling down a sheer, very dangerous cliff face just to steal a dirty puddle of water from a gutter. It defies all logic. What about minerals? What about gold or rare earth metals? Again, the cosmos provides in staggering excess. 3. Our own asteroid belt contains enough heavy metals to construct entire continents. An alien civilization capable of harnessing the power of a star has no need to dig into the crust of our planet. 3. Mining on Earth requires fighting gravity, fighting our thick atmosphere, and spending colossal amounts of energy just to lift the raw materials back into orbit. In an asteroid belt, millions of tons of pure resources are simply floating in a vacuum, completely free for the taking. Perhaps then they want our planet to live on. Perhaps their homeworld died and they need a new Earth. But think about the technology required to survive the journey. 3. If you can build a starship capable of keeping a biological civilization alive for thousands of years in the hard vacuum of deep space, you have already conquered biology and environment. 3. You have built a perfect closed-loop ecosystem. You have constructed a flawless artificial habitat where you completely dictate the weather, the temperature, and the atmosphere. 3. Why would a species that has mastered perfect artificial environments want to abandon them to live on a volatile, chaotic, dangerous rock? Earth is incredibly hostile. We have earthquakes, supervolcanoes, hurricanes, and unpredictable climate shifts. We have an atmosphere filled with oxygen, a highly reactive, corrosive gas that might be completely toxic to their alien biology. We have a biosphere teeming with microscopic viruses, fungi, and bacteria that would view their unadapted alien cells as a fresh, undefended food source. 3. The hard truth is that any civilization advanced enough to physically reach us has fundamentally outgrown the need for planets. Planets are the cradle of life. 3. But you do not stay in the cradle once you learn how to run. A species capable of interstellar travel lives in the space between the stars. Earth is a thermodynamic dead end. We are a heavy, dangerous, resource-poor gravity trap. We are safe, not because we are protected, but because we are utterly, profoundly irrelevant to the gods of the cosmos. But if they do not come to conquer, and they do not come to harvest, is there any reason they would cross the dark ocean just to say hello? So, we have eliminated conquest. We have eliminated resource harvesting. 3. We have eliminated the need for colonization. If the brutal laws of thermodynamics make visiting Earth a monumental and dangerous waste of energy, what is left? Curiosity. 3. Perhaps they simply want to say hello. Perhaps they are the ultimate anthropologists of the cosmos, mapping out every spark of intelligence that flickers in the dark. But even here, our human ego blinds us to the reality of deep time. Imagine you are taking a walk through a dense, beautiful forest. As you walk along the path, you look down and see an anthill. 3. You do not hate the ants. You have no desire to crush them, and you certainly do not want to steal their dirt. You might even find them fascinating for a brief moment. 3. You might stop and observe how they carry leaves and build their intricate little tunnels, but you do not get down on your hands and knees and attempt to teach them calculus. 3. You do not try to explain the concept of poetry or the architecture of your home or the intricate politics of human society. The cognitive gap is simply too vast. There is no common frame of reference. After a few seconds of observation, you stand up and continue your walk. Now apply that logic to the stars. A civilization capable of manipulating the energy of entire solar systems and traveling across the galactic void is not just a few centuries ahead of us. They could be millions or even billions of years ahead of us in their evolutionary and technological development. To them, we are the anthill. We are a primitive, chaotic species still fighting over ancient fossil fuels, still bound to the rock we were born on. They would not cross the apocalyptic storms of deep space in a heavy, lumbering spaceship just to have a conversation with us. But does this mean they are completely silent? Does it mean we will never know they are there? No. It simply means our entire concept of contact is flawed. We are looking for physical ships because we are physical creatures. But advanced intelligence inevitably transitions from the brute force of moving matter to the elegant efficiency of moving information. If an advanced civilization wants to reach out, they will not send a heavy, fragile metal box. They will send a photon. They will communicate using the absolute maximum speed limit of the universe. They will use light. Sending a pulse of concentrated electromagnetic energy across the galaxy requires a tiny fraction of the energy needed to move a spaceship. Light does not need a life support system. Light does not suffer from time dilation. Light does not shatter when it passes through a cloud of cosmic dust. A tightly focused laser beam, encoded with a massive encyclopedia of galactic knowledge, can slice through the vacuum of space forever. This is why we build massive radio dishes and point them at the sky. We are not looking for exhaust trails. We are listening for the whispers of the gods. We are searching for an artificial pattern hidden in the natural static of the universe. And understanding that natural static, decoding the fundamental truths of our reality, is exactly what we do here together. We are the ants looking up from the dirt, trying to comprehend the vastness of the forest. If you value this journey, if you want to support our mission to strip away the illusions and look directly at the raw mechanics of the cosmos, please consider leaving a super thanks below this video. Your direct support allows us to bypass the noise of the algorithm and focus entirely on creating these deep, uncompromising